Hello and welcome back to Compiler Programming. Today I wanted to work a bit more on inline machine code byte support, which we added a few videos back. I will link that video in the description and maybe in the corner of the video. But the way it's done right now, it's not really doesn't really offer good support for arbitrary sort of encoding of instructions, because right now we just say, okay, we can put an array of bytes in here, up to 15 bytes, and that's not enough, because we also need to have some support for labels. And right now that's not really possible. Here's how labels are handled inside of the main encoding. So here we have like if we come across a label, we basically add it into a special array that will be later patched on once we resolve all the instructions. And so we need to do something similar here. And here is the handling of this type of inline byte instruction, and that we need to do something about. So the first thing, I guess, would be to change the current setup from having this fixed buffer to having some other data structures that would allow us to specify that this is either, well, maybe that will just be allow us to say that at a particular position in this buffer, there is a label, and I think there is only can be one label in one instructions, at least in x64, but I'm not sure. We will start with that and see if that is actually true. So let's go to our header file and look up this definition. So where is it? Yeah, we have slice bytes here as the value, and that's not really great. So we'll create a new struct here, instruction bytes, and now this is going to be instruction bytes bytes. That's great. Okay, so what will this have? Well, it will, I think I will just put inline sort of array of memory, so bytes, where I'd say yeah, we'll have U16 or U8 bytes 16. In reality, there is only 15 of them. So maybe I will do like this, 15, and then U8 count or length, maybe. And then I also need to add this, as I said, a position at which we expect to have a label, and that label should also have we also need to know the index of the label that we are trying to refer to. So we need both of those things. How do I want to do this? Maybe I would say label. So we need label index, label index, and we need to have U8 a label offset, and that label set is set inside of this instruction. Set in instruction, something like that maybe, but there might not be a label. So I guess what I will do is I will just use value 255 to describe that there is no label. So like I will use U8 max to say that no, this is not a value that we can expect, and we should not be using it for encoding. Okay, so let's see what breaks. Obviously, stuff that actually puts this in here breaks, which is fine. How do I want to handle this? Well, I can say instruction bytes. Bytes is this. And then we are gonna say that. Oh, we just can actually say that everything is 0 here. That's what it will be. Okay, bytes. We don't need the. Well, actually, byte count is fine. And I can maybe actually put this here and now say that this will change in a moment, but it's fine for now. I can say U64 to U8 of byte count. Okay, and now we don't need this buffer anymore because we're gonna just put these bytes in line inside of the instruction itself. It's actually not even that much more memory because we had to store like a pointer to buffer, which is 8 bytes by itself. So we are just a bit more. Okay, we get the value, blah blah. And here what we're going to do is we're gonna say that bytes. This is a bit awkward. I really don't like when you end up with like dot bytes. But actually I'm slightly changing my naming convention recently to have it title case here when you have like this kind of union to make it more obvious that this is actually a separate sort of object or separate variant. And like that, I guess it's fine to have it that way. It's still gonna be bytes dots bytes. Maybe I'll call it memory, I guess. Let's call it memory. Memory and length. Yeah, that's fine. Bytes memory I is whatever we were doing before. So like this. And that's fine. And here we need to change. Bytes is bytes. What are you unhappy about? Yeah. Good. I think now the only thing left is encoding maybe. And here we just need to turn this pseudo slice that we added. Like this is basically sort of the same thing as we would want in a slice, but it has slightly different layout. So we need to create a slice that we can append to buffer. We can also append raw bytes, but it's not that convenient maybe. Oh, let's do that. So let me look up fixed buffer append. So there is append type, there is append slice, resizing append. I guess I don't really have a good way to just shove slice with like a bunch of bytes in there in a more C way. Well, it's fine. We're gonna just do slice. Okay, fix slice. Slice is the following. We will say that bytes is instruction bytes memory and length is instruction bytes length. Okay. That seems fine. Okay, here we can no longer do that. What we need to do is mem compare mem cmp to cast it to a boolean here. So mem compare a bytes memory and b bytes memory. And we need the size. Okay, yeah. So first let's compare the size. Let's say if a byte's length is not the same as b byte's length, then return false. Otherwise, we just take one of the lengths and pass it in here. Okay, that is it. We haven't really changed functionality so far. This was just a bit of refactoring, so hopefully everything works as it should have before. But let's see if it is actually true. And it does not. And this is kind of interesting. So what did I do differently? Put length in here. We put the bytes in here, and this should just go from from 0 to this is kind of interesting. I wonder what is the problem. Okay, let's get out the debugger, and at least we should check what is ended up in the assembly, or like, did we correctly write out the bytes? Apparently we did not, because otherwise it would actually work, but let's look at what we have compared to what we should have. So let's start here, go to the assembly, jump inside, and that does not look very good. Did I accidentally delete the actual call? Yes, of course I did. Fixed buffer band slice, buffer slice. Okay. Much better. What is the episode count? I've done a bunch of work of the screen because there was a lot to clean up with regards to parsing, and there was really nothing new there, so I did not do it in video. So we have 129. Okay. Commit episode 129. Use inline bytes for instruction type bytes. Okay, and this was the first thing. Now we are ready to actually do what I wanted to do. For that, first we will need to have a test. Let's take here and see what we can do. So first, let me reformat this a bit so it is easier to deal with. And like this. Now we want to figure out a test such that I would need a label and it would be possible to see the outcome is correct. I think what I could do is something along these lines. Okay, so this returns 42. Now we would have So yeah, let's change this function such that it actually returns the right thing. Here we would return, I don't know, let's return 0a, so it will return 10 if the things fail. Here I would say I will return the 42 we expect, and actually we don't even need to do it that way. We can have return 10, and then there will be 42, and this will be go to correct, and now we'll say labeled correct. Yeah, so this is what I want to have. Oh, but actually jumping to a label that is defined later can be a bit problematic, I guess. How do I want to deal with that stuff? So right now it is actually possible. I fixed jumping to the label, but there I know that it's a go-to. So I know that I will need to have like a label placeholder, sort of. But inside of here, I don't actually know that. Okay, can I restructure this somehow so that I can do go-to and at the same time I can okay, so this is gonna be nasty, but it should work. Here we go to skip, and then we have a label from machine code, or yeah, from machine code. Then we would have return 42 here. Need to put semicolons everywhere. And then here I would do 10. And I also need another label, which is start. Actually here. Okay, so if I run the test now, it should fail because we don't actually have the right thing to jump. Or I can for now replace it with go to from machine code, and that should do the right thing, I hope. So let me explain what happens here. We start the function, we jump to label start, and label start is defined afterwards, but that's fine. We should support that. I think there is a test now that checks for that. If not, we'll fix it. It's okay. So we get to here, we jump over to label start, and we continue from here. But that label start, what it does, it goes back to a label from machine code, and it returns 42 instead of falling back to 10. So, and our goal will be to replace this thing here with some way to specify it in machine code bytes. But before we do that, I want to verify that this actually does what it's supposed to be doing. Checker to few arguments. Actually, no, yeah, that was previously correct. That is indeed void to a64. Okay, so the function actually works. Test is fine. Now the tricky part, we are replacing this with this stuff. Okay, So let's maybe open up Firefox, and now it's gonna be very bright, so careful, you're watching that at night. And we will say go to, I don't know, who, go to who, I don't really care what is the label here. Can I do go to main? Okay. You don't want me to show it like this? I will just do it myself. Jump. Or we can look in our code actually. Instruction C and jump. Okay, so I'm interested in this jump, I guess. That is E9 and then just immediate 32. Let's verify that in a debugger that that's actually what is going on. I can go to here, go to this assembler, jump in, and yeah, that's exactly what happens. We have E9 and then we have sort of a div in jump that we need to do. That sounds good. So, okay, that means that here we should be able to do the following trick. Should say 0x E9 and then we say from machine code. I might actually consider to like do it C style and prefix it with label whenever we try to reference something, and that code basically will say, okay, if I don't know what it is, then I will kind of create a fake one that is later going to be resolved, but that is not for now. That is something later. For now, this would be the thing, and if we run now, it will fail because this is not an immediate invite, and we have actually nice error messages, I think. So let's verify that and see how it goes. Yeah, so inline machine code expects arguments to be integers, and now it is not an integer, so we need to fix that. So here we would need to say if operand is a label, or I can actually do it like this. Value operand tag is operand tag label. Then we do something. Okay. What do we do when we have a label? Well, we need to append 4 bytes. So this byte counting is no longer correct, actually. How do I want to do this? I guess what I can do. Okay, for now, I'll just disable this check at all. And this is not a byte count. This is now arg count. And we just have bytes here, which starts at 0. So the whole thing is 0. And we need to say bytes length plus plus. Okay, and here we'll just do something else. We will do the following. So first of all, actually, I need to here initialize that. How did we call it? Call it label offset in instruction. And this is going to be initialized to Maybe I want to have a define here. Define uh, instruction bytes no label 255, and I will do it like that. Okay. Probably best would be to not have label index, like have something like this in label index, and we don't really need to have it here. I don't know. I can clean up this later. For now, let's focus on functionality. Instruction bytes no label, and then I can say that bytes label offset in instruction is I, so we are at that position in there, and we need to store the index. So bytes label index is value operand label index, and here we want to just output zeros. Four of them, except for this one, and bytes length plus equal 4. Something along these lines. Let's see. You are unhappy about this. Okay, U64 to U8. And here I can say if I more than equals, oh, actually, this is wrong. This is wrong. I need to do this. Like so. Now I can check if bytes length more or equals 15, do that error. Of 15 bytes. This is a slightly different error message, but that's okay. Here I can even do the following. Okay, and that builds, but I'm actually very curious to see what's going to happen when we, I mean, if we try to run it, then things will go bad because I have not done anything here. And here we need to do stuff. So we basically need to do the same patching as here. Okay. Instruction start offset is here. Instruction end offset is here. And now we need to do this stuff. We need to add a patch. And I can say if, so if instruction bytes and then label offset in instruction, so this stuff is not, how did I call it, instruction bytes no label. Okay, If it is not that, and then we need to do the patching, and I can say label index here for the target label. From is code offset, that is correct. And patch target is a bit tricky. So patch target is why do I need end offset? Because it is offset in section. Okay. So offset in section is like so. Actually, no, not that. This stuff. Okay, and patch target is start offset plus label offset in instruction. That seems about right. 32, yeah. So U64 offset page offsets in buffer is this stuff. And here I need to say S32 star. It's actually not the great way to do it, but I will change it later. Better would be to just operate on these things. So like not store a pointer, but operate on offsets, because then we should be able to switch the buffer to like a bucket buffer stuff and still works, but doesn't matter. S32 star of buffer memory plus page offset in buffer. Are you happy now? It is happy. Now let's see what is going to happen and whether we're gonna have something nice. So something did not go well. Let's run the tests and see what is going on. We have a failed test, integer divide by 0. That is very interesting. First of all, we have a problem with test names. Should be able to reference a label, a declared label in raw machine code bytes. Is this better? Expects arguments to be integers. Yeah. I did not do the right thing. So let's do this correctly. This should be like so. Okay. Let's try that again. No luck this time either. Okay, what's going on? What do you say now? Expects argument, what? Value, dynamic array, get args. I would okay. This needs to go in here. Let's try again. Well, we at least encoded something. Now let's see if we encoded something that makes sense. I think it does actually. So we go to here, we should jump to here now, and then we will jump to here and then jump to return. So, yep, jump to here, move 42, jump to return, and return. Amazing. So now we should have correct tests. And indeed we do. Let's look at them again, just to uh, be happy about that. And that is about it. Let's see what we need to change. And that would be all for the video. Okay. So here is a change inside of encoding. That makes sense. If we have a label, we encode it. So that is a yes. Here, the change comes down to, yeah, this is the parsing change. That also looks pretty good. And we have a test. Great, that is fine. And looks like that's about it. Commit, episode 129, support, referencing labels inside role machine code. Cool. This change may not look like much right now, but believe me, it's all coming together. In the next few videos, you will hopefully see how we start to take advantage of this feature and all the parsing improvements, and we will work a bit more on compile time, execution, and hopefully what's going to happen is the compiler will start to shrink, and a lot more things are going to be done inside of a user land rather than inside of a compiler. But that is definitely not for today, that is for next times. So thank you very much for watching, and hopefully see you then.